Hello everyone. I'm so sorry I can't be there today, but I wanted to kind of explain what this activity is about. So here we have 9 systems of equations, and we learned 3 different ways of solving them. So what I might notice first is the ones that have y equals in the front. Those are going to be easiest for me to graph. We do know how to graph standard form, but not all of us like it, and that's okay. That's the point of this activity, is you get to pick which ones you want to do, what method you want to use. So the ones with y equals, probably going to be easiest with graphing. My elimination problems, I need x and y to be on the same side, kind of like number 3. Everything already has x and y on the same side, just like we see in our notes right here. So that's the kind of thing I might look for elimination. And then the last one, substitution, is what we learned on Monday, is where one of your equations is solved for, the other one is in standard form. That's the most common way that we saw substitution examples, so I might go for those for substitution. So again, y equals is going to be good for graphing. Both standard form are going to be good for elimination. And then where one of them is solved for, the other one is not, that one's going to be substitution. So if that helps you get started and you know how to do these methods, you don't have to watch the rest of the video. You can go ahead and get started. If you would like an example for each of these, I'm going to do 1, 2, and 3 on as an example. So that first one, number 1, is a good graphing one, so I'm just going to rewrite it so Miss Davis knows which one I'm doing. Number 1. Here's my equation. Here's my other equation. So the reason this is a good graphing one is because with this method, I know my slope and I know my y-intercept. Remember, for this top one, if there's nothing there, it's 1. So the slope is 1 over 1. My y-intercept is 2. Remember that y-intercept, that's 1 point we know on our graph, so that's where we start, up at positive 2. Whoops. Whoops. And then I go up 1, right 1, all the way across. Because I want to see everywhere that my line goes. Okay, this next one right here, my slope and my y-intercept. My slope is 3 over 1. My y-intercept is -2. I'm doing this kind of quickly now, so hopefully if you're still lost, you can look in your notes and see an example of this, or you can ask the person next to you. So we just graph both of them, and I notice right there, that point of intersection, that's my solution. Just remember, when you write your solution, you write it as a point x comma y. So to get to this point right here, you will write to up 4. So that's the point 2 comma 4. Beautiful. Okay, if you're ready for an elimination example, I'm going to do number 3. Let me write it down first. So again, be sure you're showing Miss Davis which number you're doing so she doesn't get confused when she grades it. Okay, beautiful. So the first thing we ask ourselves with elimination is, does anything cancel right now? So right now, my x's are different and my y's are different. Nothing cancels. So in order for them to cancel, I need them to be the same number, one of them needs to be negative. So right now, we could make our x's cancel or we could make our y's cancel. Both look pretty easy. I'm going to just focus on the x's. So I ask myself, how can I make this positive 3 into a negative 6? What's something I can multiply by? I can multiply this by negative 2. Again, I want to do that because I need this to be a negative 6 in order for those x's to cancel. So I'm going to rewrite my equation, multiplying everything with negative 2. And negative 14. Now that I'm here, I double check again. Does anything cancel? Ooh, my x's cancel. They eliminate. So I'm going to cross them out. Everything else you add down. But remember, if that says minus 8, you can just subtract. So you can think 2 minus 8. That gives me negative 6. Be sure you're getting the right letter. This is y. And then I do 8 minus 14. And I get, again, negative 6. Now I'm just solving for y. Divide both sides by negative 6, and I get positive 1. There's my y value. If you run out of space in these little boxes, feel free to use the back or use a separate sheet of paper. I tried to squish them all onto one page. Anyway, my next step is to plug that answer back into one of my equations and solve for that variable x. So off to the side, because I am running out of room, I'm going to rewrite this middle equation. Again, it doesn't matter which equation I use. They're all going to give me the same answer. That's what it means to have a system. All I did was rewrite it. Now I'm going to plug in what I got for y. So I leave everything the same. When I get to y, I open parentheses, and I'm going to plug in what I got. I got 1. Now it's just a matter of solving for x. So to make my life a little easier, I think 2 times 1, that's 2. Don't forget those simple solving steps. Subtract 2 on both sides. Divide both sides by 6. And I get x equals 1. They're both 1s. Kind of funny. It definitely happens. Won't happen all the time. My solution, be sure you put x first. Doesn't really matter because they're the same number in this one. But that is my solution. Wonderful. Okay, now I'm going to do a substitution example. So number 2, hold on, let me see what it is. 2x minus 1y equals negative 3. 3x plus 1. Okay, beautiful. So again, be sure you're showing Miss Davis which number you're doing so she doesn't get confused. Okay, substitution. This is the last method we learned. Gotta turn your brain around. Be sure you have your notes out with you. First thing you look for, which letter is already solved for? Meaning, do you see x equals or do you see y equals? For this one, I see y equals right here. So I know I'm plugging into that y right there. It's saying these two y's are the same thing. So I can substitute in all of this in its place. Okay, so I take the long equation and I rewrite it. Remember to open up your parentheses really, really big when you get to y. So I don't write the letter y. I open up my parentheses, leaving a lot of space in place of y. So again, I just rewrote that top equation, leaving parentheses in place of y, so that I can plug in what the other one says. The other one says y equals 3x plus 1. That means 3x plus 1 can take the place of y. So I write it right here, like that. Once you get that first step, now it's just algebra. Remembering how to solve equations. I got to distribute that -1. -1 times 3 gives me -3. X. -1 times +1 gives me -1. Again, now I'm just solving. So I want to combine my like terms. 2 minus 3 gives me -1. Everything else stays the same. I'm going to add 1 on both sides. Again, don't forget those simple solving steps. 3 plus 1 is 4. Divide both sides by -1. I get x equals -4. There is one of my letters. Wonderful. Remember now I need to find my y. So this is where I plug that answer back into one of my equations. Now technically again, it doesn't matter which equation you plug it into, you'll get the same answer in the end. But one of them is already solved for, meaning it's just going to be a lot easier for me to plug into. So I'm looking at this one right here. Y equals 3x plus 1. It's saying y is 3 times whatever I got for x plus 1. So I'm plugging in that value I got for x. I can plug that into my calculator, or I can think it out. 3 times -4 gives me -12 plus 1 gives me -11. So my solution, again, remember to put x first. I have -4, comma, -11. Beautiful. Okay. If you need any help with any of these systems of solvings, remember I have pictures on Google Classroom with examples of everything that we did in class. Please use the people around you. Make sure that you fill all of this out, showing Miss Davis which problem you're doing. Turn in everything at the end of class. Okay, wonderful. Thank you.